So hey everyone, welcome back to another video. So in this video we will see how you can make this beautiful 3D scene with Three.js. So as you can see, I have a Three.js scene in which we have a plane and there is a create button. So as soon as I click on this create button, a cube will fall from the sky, and whenever I click a create button, more cube will fall from the sky and they will fall to the ground. And as you can see, whenever a cube will fall out of the boundary of this platform, it will fall to the bottom. So it is a pretty simple Three.js scene in which you can practice your Three.js, and also you can include this scene in your websites, or you can make it own by customizing it. So in this video we will see exactly how to make this 3D scene with Three.js. So let's head towards the VS Code and see how it is done. So I am in now VS Code and I have two files. First is index.html and the second one is script.js. So let's first write some HTML part. So I will first create the boilerplate, and then inside the body tag I will make a button. First of all, before creating a button, we will create a div which will be our canvas. So I will give it an ID of canvas, and inside this only our Three.js scene will lie. And after that I will create a button and give it an ID of btn and write here create. Then we will do some styling, some very quick styling. So I will set the margin and padding for all the elements 0, and then I will style the button a little bit. So first of all I will give it position absolute, then from bottom let's say 20 pixel, and from left let's say 48 VW, and then I will give it a padding of padding, let's say 10 pixel, and then font size of 1.5 rem, and then font weight of 900, then border radius of 10 pixel, and finally background color of cyan. So that's all the CSS we will write, and after that we will write some CDN. So if you don't know what CDN is, it will allow to use Three.js without installing Three.js in your app. So come to a new tab and search for JS Deliver CDN. So it is a famous platform for CDN. Here you can find various CDNs. So here in the search box, search for 3 and click on this first link here, and you can see this is the link you have to copy. So let's just click on copy and copy HTML, and then you have to just paste it after the body tag, and there you go. In this way we have installed Three.js in our app. And similarly I will just copy this down over here, and we will do some changes for orbit controls. Okay, so after this 3, here I will write here examples and then /js /controls, and then remove this 3.min, and instead of this I will write orbit controls. So that's it. That's all you have to do in order to import orbit controls with CDN. And the last CDN is canon.js. So if you have seen, there is physics involved in our scene, so this is due to canon library. So here search for canon es, search for canon es only, and as you can see we have some code over here. So you just have to copy this URL. So I'll just copy this URL, just that, and then come to our VS Code, and here what I will write, first of all I will write script, and then first of all I will give it a type of module. So make sure to give it type module, because we are going to import this canon es in our JavaScript file. And then obviously src, here I will write script.js. So in this way we are using this script.js in our HTML. So here now we have to write import star as canon from this. So that's all you have to do to import Canon.js in your JavaScript file. And now let's write some JavaScript to make our Three.js scene. So first of all, we will write some boilerplate which is written in all the Three.js file. So first of all, we will make a render object. So I will write here renderer, just like that, and this will be equal to new 3 dot WebGL1 renderer, and in the bracket, so leave the bracket empty for now, and I will write here renderer dot set size. So now we will give the size of the Three.js scene. So how large we want our scene to be. So we will just give the width and height of our window. So it will just get the height and width of this laptop. So I will write here inner width, and then window dot inner height. That's it. And then we will insert this Three.js scene in our canvas element. So as you know, we have created a div and give it an ID of canvas, and now we will use it to insert the Three.js scene in it. So I will write here get element by ID, and I will get the canvas element, and then I will write append child. So we will append this 3D environment in our canvas. So I will write here render dot DOM element. So make sure to write this, and then we will create a scene. So after creating this environment, so this renderer is used to create the environment. Now we will create the scene in our the objects, the 3D objects will lie. So I will write here just 3 dot scene. That's it, and make sure to give it a, and make sure the S is capital. And after that, we will create the camera to see our scene. Okay, and then similarly new 3 dot, and here you have to write perspective camera, and then you have to give some values in the bracket. The first one, let's write some 75, and then you have to write window dot inner width divided by window dot inner height. So don't worry what these values are, it is just used to make your camera movement and camera angle accurate. Okay, so I will write here 0.001, and then last value you can give a large number, so I will just give it like a very large number. And then after that you have to set the camera, so here you will set your camera. So I will write camera dot position dot set, and inside this you can give x, y, and z value. So I will write here -7, 15, and 15. This is a pretty good angle. Then what I will do, I will write the function, the last function for the JS, for the Three.js. So I will write here function called animate, and inside this I will write renderer dot render, and then in the bracket I will add scene comma camera, and after this we have to call this function. So I will write here renderer dot set animation loop, because this animation will occur in a loop, so that's why we have written set animation loop, and then you have to give this animate name. After that you have to write some more code for the resize of your screen. So whatever code I am writing now, it is used just for the resize of your 3D scene. So whenever you are changing your device, this function will occur, and it will just adjust your 3D scene in order to be seen by, and it will just, so I will write a window dot add event listener, and in this I will write here resize. I will make a function, and then I will write here camera dot aspect. So don't worry about all this code, it is just used to resize your 3D scene based on your device. So you can say it is used for responsive website. and I will write here inner width slash window dot inner height. That's it. And then camera once more dot update projection matrix, and then give it a bracket, and then finally renderer dot set size, and similarly we will give this thing. So I'll just copy it and paste it over here. That's it. So our 3D scene is now ready, and the only thing left is to create the objects and to add physics. So let's see, let's go live and see what our website is looking like. So as you can see, our website is looking something like this. There is our button, and you can see there is a black screen, and this is the by default color of the 3JS scene. So don't worry about it, it is just fine. And one more thing I will write in our CSS is cursor pointer, so that there is a cursor when we hover on a button. So there we go. So now let's add an 3D object in our scene. So I will come down here under the camera. Let's make a 3D plane. So first of all, I will write here ground geo. So to make any element or any 3D object in 3JS, you have to first define its geometry and then give it a material, and then finally add both of these in a mesh to the scene. So first of all, we will define the geometry of our plane. So I will write here new 3 dot plane geometry. So because it's a plane, we have to use this plane, and then I will give it width and length. So this is the length and breadth of that 3D plane. Then we have to give the material. So I will write here ground mat, and here I will write new 3 and dot mesh standard material. So make sure to use this only, and then it will take some value. So then you have to give it a color. So I will write here gray, you can give it anything. And then for this side I will write here p dot double sided. Okay, double side. That's it. And then as I told you, we have to create a mesh and then add it to the scene. So I will write ground mesh is equal to new dot 3 dot mesh, and then you will just give ground geo slash ground mat. That's how. And this is the this ground mesh is the 3D plane. So now we just have to scene dot add and then ground mesh. So that's all. And now if you will look in our screen, so okay, so the plane is not there. So let me see what is the problem here. Alright, so to see the plane, we have to give lighting also. So for the lighting, we will use two types of lights. So the first one is ambient light. So let me explain what ambient light is. So first of all, I will make a variable called ambient light, and then I will write new 3 dot ambient light and give it a color of white. So what this ambient light is, this light will reflect from other objects. So that's what ambient light is. And then we will just write scene dot add and ambient light, and there you go. And now let's see our scene, and as you can see, you can partially see our platform. There is our platform, and if you notice, we cannot move this scene, we cannot rotate or anything. That's because we haven't like install or use our orbit controls. As you can see, we have written the orbit controls in our CDN, but we have not required it in our JavaScript. So let's do that. So it is very simple. You just have to come under the camera and then write orbit dot is equal to new 3 dot orbit controls. So orbit controls just like that, and it will take two arguments. The first one is camera, and then second one is render dot DOM element. There you go. And then you have to write orbit dot update. That's all. And so it is giving me an error. Let's see. So as you can see, it is giving me an error, and it is even not showing any 3GS scene. So that is because we have installed our orbit controls in the new version of this 3GS. So what I will do, I will just simply write over here with 134.0. so it is a previous version, but it will work. So make sure you have changed this to 0.134.0. and now if you will see, you can see there is our platform, and now you can even move it. So you can move it, rotate it, and even zoom and out, and there you go, there is our platform. So now let's make our scene. So to do that, so now let's complete our 3GS scene. So now what I will do, so now I will add two more lights. I have told you there are two types of lights we will be using in this tutorial. The first one is ambient light, which we have installed, and then the second one is spotlight. So I will write here const spotlight is equal to new 3 dot spotlight, and then give it a color. So I will write here color, and also a value of 10. So there you go. And now I will change the spotlight power. So how powerful will the light be? So I will give it power of, let's say, 1000, or let's say 10,000, and then simply I will just add it to the scene. So let's add it spotlight, and then what I will do, I will change the position. So first of all, I will change the angle. So let's say angle is equal to 4, and then spotlight dot distance, I will change the distance to 40, and then spotlight dot position. So finally the position, so I will set it to 20 slash comma 20 and comma 0, and I will add one more spotlight. So I will just copy it and paste it down over here, and instead of this spotlight I will make spotlight 2. Oh, oops, spotlight 2, spotlight 2. So just do the same thing for the spotlight 2, and the position, we have to change the position of it. So instead of this this 20 for x, I will write here -20, and that's all. You cannot see any difference, but you will see when we will add an 3D object in our scene. So now almost everything is done. We just want to create the object when we will click on that button. So first of all, let's make another element, which is a cone, which I have shown you in the first part, which I have shown you in the intro. So to do that, I will just simply copy this ground, and instead of this ground geo, I will write here cone geo, and then cone mat, and then cone mesh, and this is a cylinder. So we will make the cone with the help of cylinder geometry. So it will take some values. So let me explain what these values mean. So the first one is 0. So this is the radius of the topmost part. The second one is the radius of the bottommost part, and then this is the height, and then this 100 is the radius, or you can see the border radius. So the color of it, I will make it brown, and move this double side, and make sure to change these also. There you go. And add cone mesh in the scene. So as you can see, there is our cone of brown color. Alright, so now it is time to add physics in our Three.js scene. So to add physics, we will use Canon.js. So first of all, I will make a variable called world, and then you have to write new Canon. So this is our new variable, and then I will use world. That's it, and it will take some arguments. So first of all is gravity, and then it will be new dot Canon. There you go, dot vec3, because of vector 3, and it is used to create 3D elements, and the first value is 0 and the second value is minus 9.81. So if you notice, this is the exact acceleration of our gravity. So there you go. You can change this value if you want to change the acceleration of the gravity in the Three.js scene, but this is the example for real life, so we will be using real life value, which is 9.81. So after creating this world, now we will add physics to our plane. So if you notice, we have to add physics to our plane, then to our this little cone, and then those boxes. So first of all, let's add the physics to our plane and this cone. So for the plane, I will write here ground physics mat. So this is a short form. I will write here new Canon dot material. Alright, that's it. And then another variable called ground body is equal to new Canon dot body, and then it will take the arguments for like the width and height of your shape. So the first one is shape, then you have to write new and then Canon, then box, because our plane is something like box but without any height. So what I will do, inside this bracket I will write new Canon dot again vector 3. So in Canon, only vector 3 is used to create any 3D element. So as you can see, I will give it an width of I will give it an width of 10, length of 10, breadth of 10, but height will be 0.1 because it is very thin. Don't give it 0 because then it will just do not exist. So the second argument is type. So what type your physics object is. So I will write over here Canon dot body dot static. So you have to write exactly that, and you have to write static in caps. And the final argument is material. So if any material you want to give it, and that's you have to give it this ground physics mat, and there you go. You just have to add this to our world. So I will write add body. It is similar to scene, but in Canon.js you have to write this world.add body, and in scene you have to write scene.add. So there are some difference. So I will just copy ground body and add it here, and there you go. So let's save it, and you cannot tell any difference because we haven't give any physics to our cone. So let's do this. First of all, you can see the plane is clipping through this cone, so we have to rotate the plane. So to rotate the plane, what I will do, I will select the ground body called Quaternion. So this property is used to rotate any 3D object in our Canon.js. Then I will write here set from Euler. So this is a function to rotate it, and here what I will write math.py is 2. So this will give exactly 90 degrees, and then for the y and z axis I will give it 0 degrees. This math.pi/2 is minus 90 degrees in x axis. So let's see now. So it is giving me an error, and let's see what is the problem. Alright, so the spelling of this is not quaternion, it is quaternion. So make sure to do it right, and there you go. If I just reload it, you can see our platform is looking something like that. Now similarly I will do the same thing for our cone. So I will give the physics to our cone. So here I will write, instead of ground physics mat, I will write cone physics mat, then cone body, and then here cone physics mat, and then cone body. And also we have to change these values because it will be a then plane and not a cone. So instead of this box I will just remove all of it, and I will write here cylinder. Okay, so it will be a cylinder, and similarly I will write here 0 1 1 and then 100. There you go. And also we have to give it a position. So let's change the position of it. I will write here position, then new canon, new canon dot vector 3, and there you go. We have changed the position. Don't forget to add a comma over here and here also. And now we have to give the mass. If you notice, we haven't given any mass to our ground because it is a ground. It should not contain any mass. It is an infinity mass. So but for cone we have to give it a mass, so I will give it an 10. All right, there you go. 10. I think 10 will be enough. And you can see nothing will happen because we haven't add this, like we haven't combined this physics to our actual cone and plane. Okay, so to do that, what I will do next is, first of all, you have to make a time zone. So I will write here called time step is equal to 1 divided by 60. Just do it. Then what I will do, you have to come under this animate function, and inside this all the magic will happen. So I will write here world dot step, and then I will give it time step. In this way our physics world will also animate with the actual 3D scene. Then what I will do, I will write here ground mesh. So ground mesh dot position dot copy. So what I am doing here now, let me just first write and then I will explain. I will write here ground body dot position, then I will simply copy it. I will write here quaternion and then quaternion. I will do the same thing for the cone. So here I will write here cone mesh, then little cone mesh over here, then cone body. So what I am doing here, you can see this is the physics body and this is the actual 3D element in our scene. So I am just copying this position of this body to our scene, and this is the way you have to combine this actual physics to our 3D element. And now if you will take a look, you can see, as you can see, the cone falls from the sky towards the ground. So let me just reload the page, and there you go, it falls to the platform. So that's how you can add physics to your 3GS scene. And now let's make the most important part of the video, which is to create boxes when we click on the button. So that will be also very easy. So first of all, let's come under this const time step and make two more arrays. So first of all, I will write here meshes will be an empty array. Similarly, bodies. So these two arrays will be there. Then what I will write document dot get element by id and then add btm here and then dot add event listener and click. So whenever someone will click on the button, so there will be a function which will trigger. And what will be the function? The function will be const box. So this will be just similar. So I will write here box geo. So we'll make a new box every time when someone will click. So I will write here box geometry. There you go, box geometry, and then give it a height, width and breadth. So 222. Then const box mat will be new 3 dot mesh standard material. So there you go, and it will take some arguments. For now I will just give it color red. That's it. And then I will write here, let's say box mesh box mesh is equal to new 3 dot mesh, and then I will write here box geo slash box mat. That's it. And then we will just add it to the scene. Okay, there you go. And not only that, after adding this 3D element, we have to also give it an physics. So I will copy this thing from our cone and paste it here. Oops, just like that. And then instead of this cone, I will write box here, also box, and then box over here, and then box over here. So just like that. And also we have to change some values, obviously. So the shape will be of box, and inside this bracket we will write one more new canon dot vector 3, and I will write 1 comma 1 comma 1. And the reason I have written 1 1 1 instead of this 2 2 2, because the physics in physics world everything is half the size of the 3GS world. So that's why I have written half the value of 2, which is 1. So make sure you have also given it half the value. And the position I will give it 0 comma 20 comma 0. This 20 will be of y-axis, so it will fall from way above. And I think that's it. And after that we just have to write meshes dot push. Okay, so to push in an array, and here I have to write box mesh. There you go. And then for bodies dot push, and here what I will write box body. So I think we are all done, and the only thing left is to animate it. So now you have to go back to the function animate and come under here, and we have to make some for loops. So I will write here for let I equal 0 and then I less than meshes dot length. So I will write here meshes dot length and I plus plus, and now I will write here meshes I dot position dot copy comma bodies I dot position. I'll just copy it down, and instead of this position I will write here quaternion. There you go. I think that's all. Now our 3GS scene should be ready. So let's click on this button and see what will happen. So let's see. And yep, as you can see, a box will fall from the sky and it will just land on the platform, and there you go. As many boxes you want, you can add by click on this create button, and it also falls off the platform. And this is a very cool looking Three.js project, and you can add it in your website. You can modify, you can customize whatever you want. So this is a like pretty basic example of what you can do from Three.js. It is an amazing tool, and you can create amazing Three.js websites, 3D websites with the help of it. So I think that's all in this video, guys. And yep, one more thing, if you want to remove this background which I have shown in the intro, you just have to do come here in the WebGL renderer, and then here you have to give it an alpha 2. So that's all you have to do to remove the background. So as you can see, now the background is not there, and there you go. In this way you can create a scene like this. So I hope you enjoyed this video, and that's it in this video, guys. I will see you in the next one.